at least get us area and land to be able to use, and then be able to do basically what we're doing here, commercial expansion. So once we are able to do some commercial expansion, we could show the algae cultivation systems, we could show floating island systems that treat nutrients, coupled with floating solar panels, because they're complementary to each other. Seawater farming systems are really locked into the initial intake portion, and then you have alternative farming systems. This is a beautiful diagram that we worked on for a competition about 6 years ago, Ned. And this is for an island, it's the southeast side, where it's really discussing how you kind of create a different environment. You create an area where people are taking little boats and renting boats as that eco-tourism generator, but it's also productive. And then most interestingly is the city scale, right? If you can imagine, these systems are cities becoming waterways that are more ecologically intertwined with. It creates a different type of economy and ecology. This is just really interesting. We're almost done here, and then we'll jump to everybody. But thinking about these systems as plug-in options, right? Those shipping containers, if you think about, this is a little design of my house, which has a little container next to it, a half-size container. You can imagine a portion of that does wastewater treatment, another portion does anaerobic digestion, another portion does hydroponic systems for food cultivation. Essentially what you'd have here is a package that costs you $40,000, $50,000 maybe, and it might be enough energy, food, you know, it could be your full spectrum off-grid situation that could be plugged into any house, or it could be plugged into 4 houses, or plugged into a high-rise, plugged into a coal-fired power plant, plugged into a nuclear power plant. These are really interesting. You can use algae systems to treat nuclear pollution, which is interesting. Maybe not safe, but so we have an area in which we can green the arid areas of our globe and use that seawater on land mixed in with these alternative energy production systems, be 150% neutral, right? The scales start magnifying once the system is proven. So our goal as Aegis Inc., as a professional project management group, is to bring all of these partners together at the same table and be able to show the complementary benefits and the complementary nature of each individual system. But then those systems combined together have their own economy, their own scale, their own complementary nature. So this is a group of us now. I'm hoping that we'll get a couple more pages in the next couple of years. For me, it's been an easy sell. I'm not selling anything, but I'm having a conversation 7 years ago, or when you came to our final crit, right? We're having a conversation about us working together and us having a mutually beneficial relationship, and that's the thread that we're taking to each of these companies. I would like to showcase your systems, and I'm going to give you free marketing services as long as we're able to utilize your systems and show that they work in combination with other systems. So that's us looking at the micro and the macro. Actually, that one should be duplicated for all of these, right? Because we have micro, we talked about that earlier, micro, macro energy, we have micro and macro economy and environment. And then the next 2 slides, and then we'll talk about, I guess we'll introduce you first, Ned. Would you like to talk about the H20 future systems?
Sure.
It's really exciting. Please.
Okay. Aaron, could you go back 2 or 3 slides and let me borrow your...
Oh yeah, of course. Yeah, show the site plans. Go back. The site plans that he has. There you go. Yeah.
Okay, well, I'm going to be speaking, again, my name's Ned Doherty. I'm with H20 Futures. I'll be speaking not in this building, but downtown at the library on the 17th, right? September 17th. So what I'm going to do real quickly here is just, I want to leave lots of time for questions, but I want to run through and just give you kind of a teaser about what my life is about in terms of seawater and so forth. So, I've spent about almost 30 years working with seawater in some capacity or another. When I say seawater, I mean completely untreated seawater. So we take the water directly from the sea and use it to harvest the natural nutrients and proteins that come from the ocean. It's such a rich resource, and for some reason we ignore that. And I've done projects in Mexico, Saudi Arabia, and in Eritrea, which is on the east coast of Africa. That's our most recent project. That was about 2,500 acres. And we did a full, what we call a fully integrated system. And I'll just go through this, use this diagram as kind of a model to, again, just give a very brief overview. And when I speak on the 17th downtown, I'll be going into great detail about how these systems work and why they're so viable to many of our problems today. So essentially what we do is take the seawater directly from the sea. We bring it in these canals. Actually what we call them are seawater rivers. And we use it, the first tier, we use it as in an aquaculture system where we grow shrimp and tilapia primarily, but also many other things. It can be bivalves and all sorts of animal products. And then we use the nutrient-rich effluent from that process to we pump it up onto higher levels of rivers and then let it drain down and become a nutrient source for all this farming activity, where we primarily grow, right now the main crops are Salicornia bigelovi, and around the edges we have interplantings of mangroves. Now that might not be appropriate here because that's really not a native, but Salicornia certainly is. It grows everywhere around the world from the equator up and down about 35, even 40 degrees latitude. So, but there are many other halophytes. Halophytes are plants that grow in pure seawater, and in fact, there's about 2,000 that we have looked at, studied, and reviewed, and they grow basically from freshwater in a range of salinity all the way up to 40,000 parts per million, which the ocean out here is 35,000 parts, so it's even more saline than seawater. But the Salton Sea, on the other hand, is even more. It's up around 50,000. So, but there are plants. Some of the plants do grow in that, and that's one of the things I'm very excited about. Is, as Nathan was talking about the selenium and all the, as the sea recedes, it leaves these beaches of very toxic material that tend to blow in windstorms and very harmful to health. We can plant that with certain halophytes right now. We could be doing that, we should be doing that right now to stabilize that, and this plant also can be used as a fodder material. Anyway, that's a whole other thing. So we use the water, we bring it in, we grow animals in it for commerce, then we use that to drain and irrigate all these fields of crops, and gradually it will drain down into a constructed wetland. And the reason that our system is really superior to most commercial aquaculture facilities is that because of this becomes like the liver and the kidneys of the whole system, in that it filters all the water before it goes directly back into the sea. So what that does, it prevents the recycling of potential pathogens and nutrients and so forth.
Well, and that's a really important system because it uses naturally untreated seawater.
Yeah.
And the opportunities are everywhere. Mm-hmm. It's a little bit harder here in San Diego where prices of property are so expensive, but you can imagine these systems being piped in for local use if we can then showcase how these systems work.
Exactly, and keep in mind that it's not just for commercial uses. We should be, the Port of San Diego covers, the whole area around the bay. The port controls all that land, and so they use about 4,000 to 5,000 acre feet of water per year of our precious fresh water to be growing lawns and landscaping that is completely unnecessary. We should be using the seawater to do that and free up that much water. So I've been on a campaign to try and get them to understand that, along with, in fact, I'm going to be posting on some petition sites online to try to get a petition to go in front of the mayor and the governor and other people to get them to realize that we need to start with the small scale. If people don't believe it, I mean, I've been doing it, it works, I know that. But to show people so they can come out to a demonstration facility and actually say, yeah, this is very good, it works.
And
So,
it creates habitat. Most
Yeah.
importantly, so I work at Development Services downtown with the city of San Diego too, and they opened up an opportunity for us to submit ideas to save the city money. And my proposal was, in partnership with Ned, to use seawater, if it's only seawater grass, right? Turn your regular lawn into seawater lawns at 25 cents a square foot, and you could save 1.4 million a year in water cost.
We proposed that for the Mission Bay area.
Right, sorry, yeah, that's the
Again,
introduction,
yeah, so
right?
it makes so much sense, and I'm not sure why, but maybe vested interest or something, but there's been this resistance of, yes, sir?
Yes.
You might find a better audience in Chula Vista.
Yes,
If they're
that's a very
new-
good idea.
New development, and they
Yes.
have that park down there.
Yes, very good idea. I have had my eye on that, but I haven't actually talked to anyone yet, so.
Well, that's good for anything, any of this discussion that we're having here. These systems can be utilized. If anybody does know, Mission Bay and San Diego Bay are technically a dead zone, right, because of the nutrient pollution. So you can install floating island systems coupled with
Right.
seawater farming systems,
Yeah.
coupled with photovoltaic